Oh, let me try to fix that. Usually it's there. Mm, do, 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 do. So I've added you as a co-host. Probably now you can. Can you try again?
Yeah, now I can.
Perfect. Let's go. The recording is on. So yeah.
Yeah. So, guys, if you can see my screen, like drop a okay or something in the chat. Got it. So let's start with the session, and I'll start with the session, and we'll take the questions at the last. Mostly, it will be a discussion because the most of the part is theoretical, and we'll discuss as we go. So let's start the session, and so here we are with the main purpose of our learnings today is how to make production grade LLM applications. And I'll share these slides later, but I've shared them in the like the starting. So let's start with the session. And this is like my Twitter account where I personally live. And if you can reach me ever, you can just DM me on Twitter. I'm every day on Twitter, and I'm every hour, every minute. I'm just sitting on Twitter. I'm a very Twitter nerd type of guy. So this is a bit about me. I'm an AI engineer and a full stack developer. Currently, I'm in a contract with some company and working with them on a contract basis. But I've also worked with remote US startups in the past. And I've also developed a couple of products of my own. And one was called Hackforge. Hackforge was basically a landing page generator. And you guys may know about Rollout from Dukan, CTO Subhash. They created it. I created a small prototype version of it alone with only me, 3 or 4 months before it was released. So I'm having experience in the game. I've have a skin in the game like for around 2 and 2.5 years. So that's why I feel I am on a level to instruct people on how to build cool apps. And also working with a lot of companies, you get a lot of experience on how AI is implemented. So that is why this is the main motto of me taking the session today, to get this knowledge out to people who haven't worked a lot in corporate environments, who haven't made a lot of production applications, to basically get people out of those chat with PDF type of applications. Because mostly people build a chat with PDF application and think that this is what an AI engineer does. But what an AI engineer does, um, a lot of things, basically AI engineer does a lot of things, and chatting with PDF, like using RAG basically in that, is one part of it. So let's see. And what is this session about? This session is to grow you out from making chat with PDF apps and API calling. So most people think that calling an API makes them an AI engineer, but that's what it is not. If you see apps like bolt.new, if you see apps like Lovable, if you see like apps like Rollout, you may feel that they are simply calling an API, but it takes a lot to instruct these LLMs to kind of make them useful for their work case and useful for your use case, basically. So that is what we are going to learn today. And let's start with some LLM history. So how LLM started and what are LLMs on their base. So if you guys know about LLMs, in the hindsight, LLMs are just next word predictors. So what they do is, in the base, when you train a model, you get a model that is called a base model. Like, what the base model does is it is trained on a lot of internet data. So what companies does is, companies like OpenAI, companies like Anthropic, they train models on a lot of internet scraped data. So there are data sets called the open web data set, the fine web data set, the fine web education data set. These are the name of some data sets that have been made by scraping the whole internet, and then a base model is tuned on it. Okay. So the base model that is tuned, it has a specific architecture. It is trained using deep learning techniques, and the architecture is called the transformer architecture. So you guys may have heard a lot about like transformers going on in the boom recently. So transformer architecture was developed by Google in 2017, and it was introduced in a very famous paper that is called Attention is All You Need. So transformer has a component transformer basically works on the concept of attention. But we won't go a lot of like into attention and the technical part. because we are like today trying to see how to apply LLMs into real life, and we don't need a lot of technical specifications for that. We just need a bit of logic building, a bit of system design, and a bit of, we can say, creative thinking to like get what you want out of your LLM. So now coming back to the training part, what happens is transformer architecture is taken, like a very template type is taken. We can say transform as a template, and a lot of like internet data is fed into it, and then it learns from that data on how to write. So we can basically take it as an example of, let's say you haven't ever uh, read a specific author, but I like give you 100 books of the same author. If you read 100 books, after reading those 100 books, you will be able to write in the same or similar style to that of the author, because by reading the books you will start to like identify some patterns, you will start to identify some things. So if I tell you that this is a page from the author's book, if can you extend it to write a full book, probably you will be able to write it in a similar fashion, although not the very same fashion, because there are a lot of variations in a book, but you will be able to complete that page in a similar fashion. And that's what a base model does. When a base model is trained on a lot of data, it actually is able to write the next word. So for example, if you give it a string, let's say Hitesh is going to the market, it will start completing that string. Hitesh is going to the market, then it will output Hitesh is going to buy some things, Hitesh is going to spend XYZ rupees. So this is what will start to happen. Now the LLMs we use chat gpt, we use Claude, we use Llama. But when we ask them a question, they don't complete the question. They give us an answer. Now, how does that happen? That is a part of the training process. So, what I just described was, it was pre training. I have also written it pre training here. It was a part of pre training. Now, what happens is these LLMs are fine tuned. You guys may have heard about what is fine tuning. This is the very first use case of fine tuning that was done on things like LLMs. What happens is we do instruction fine tuning. Now what is instruction fine tuning? Now for fine tuning we need two or three components. First is the data set, second is a prompt template, third we need an actual base model to train on. Now what are these components? Let me break them down for you. uh, Let me share an Excalibur. So if you guys can do a thumbs up if you can see the Excalibur screen. Yeah, got it. So what is instruction fine tuning basically? Now we can say that we have a base model actually. Okay, now that base model, what that base model can do at on its own, that base model like on its own, it can only complete sentences. But what it cannot do is like it cannot answer our question. So what happens is we do instruction fine tuning. Okay, and like there are three components as I discussed about instruction fine tuning. As let me make a diagram. So there are like three components to instruction fine tuning, and the first one, as I told, is the data set. The actual data set of the domain you want to fine tune. For example, there will be a data set for medical question and answering. So that can be used to train a base model that is like good at biochemistry, or we can say something is good at a law, something is good at tech. So if you have ever used Cursor or something, the specific models, Cursor has a specific model called Cursor dash small. If you don't have a Cursor subscription, that is what it defaults to. It is trained on this data set, the coding data set basically. That is the data set, and then you and then you need a prompt template basically. Now, what is a prompt template? It is the way that the user will be giving you the data, because let's say we have a data set. Data sets are not always ideal. Okay. data sets don't always describe like the real condition in which the user will ask the answer. If, for example, you use ChatGPT, we write very informal queries. For example, we write queries like fix this code, or sometimes we write fix this error, but we don't give a lot of information, right? So this is what prompt templates do. They standardize the way the things are in dataset so that the LLM can like identify a kind of pattern. Okay, I'll write a prompt template like as an example and I'll tell you guys after that. And then we need the base model. Base model is the thing you fine tune using dataset and prompt template. Now, what actually happens is, let's say we have a prompt, we want to uh, instruction fine tune on a dataset. Now, what will we do is, what our prompt template would be, our prompt template would be a, a Q&A tool basically. Sorry, not a tool. It will be a Q&A template, and it will like somewhat looks like this, that the question would look like this, and you can enter the questions from the dataset here, and then the answer, and you can enter the answer from the dataset here. Okay, so what will the LLM infer is, let's say the schema of your dataset, like the dataset you made, uh, it'll look a bit like this. Now you can just say there are some questions on this row and there are some answers on this row. So the question will be here, the answer will be there. Now, using this template, using the template of question and answer, the base model will be then trained. So the base model will know, okay, if I get something like a question, I don't have to follow the question. I have to actually answer that question. So this is what basic instruction fine tuning is. So let's say you take a question called who was Napoleon Bonaparte, and you have the answer. So it will know that when a question comes like what is Napoleon Bonaparte, and there is a, we can say, an intent of asking a question, the answer continues, not the actual question continues. Okay, so this is how LLM or the base model that is trained, it knows how to actually answer the question. Now you guys may have heard a lot of things about GPT and OpenAI, and there are some lingos that you guys may need to know. Now, with the specific OpenAI's ecosystem, GPT is the base model. Okay, what we use is Chat GPT. Now, Chat GPT is the instruction fine tuned model. Okay, so like if somebody asks you what is GPT, GPT is actually the base model. We heard about GPT 3, GPT 3.5, GPT 4, GPT 4o. These are all base models. And Chat GPT, the product we use, Chat GPT is actually the product based on the GPT model. It is a instruction fine tune model. Got it? So any doubts till now, you guys can ask if there is any specific doubt, or should I continue? Got it. So I'll continue. Now, like we know a little bit about how LLMs work and how are they trained, how are the instruction fine tuned. So we'll next go to asking why API calling is glorified. Now, what people like to make is they'll make an app called, let's say, roast your GitHub type app. So they'll take some GitHub data, pair it with a prompt, and get an answer, and they'll call it an AI product basically. Now, calling an API is the most low effort job. So now this is a reply I gave to someone on some question. Now this is the link, you can actually go and visit this and see the original tweet. This is a cutout part of the tweet. So this is from where I got the idea for this session basically. And I literally, on this tweet there are like 7 or 8,000 views, and some people are appreciating me, some people are bashing me like, why are you writing this? API calling is the engineering. But what happens is there is a mass user pool of people who only on their fundamental, like on their fundamental skill, know how to call APIs. Hence there are a lot of people who call APIs and call AI engineering. So if you see on Twitter, a lot of people will call themselves AI engineers, but they will not do the best practices. They will just call an API using some data and call themselves AI engineers. But that's not what AI engineering is. So I tell you that real AI and LLM engineering is not like this. For example, this project, I think this was some MCQ type of project. You give it some data set, it will generate some MCQs. Now, this was just an API calling thing. But there are a lot of nuances to this app that you can actually implement. Now, this was my suggestions on the app. It was like implement guardrails, work on the citations, parsing the prompts, and writing the evaluations. Now, if you do all of this, you ensure that your app is safe using guardrails, your app is trustworthy using the citations, and your app is reliable using evaluations. Okay, now I'll about these. Now, somebody was asking in the chat, what exactly is an AI engineer? So there is a very good link by someone called Swix. Swix is a very famous person. If you have ever heard about AI.engineer, AI.engineer is a forum, and their events happen in SF. They host something called the AI Engineers World Conference. So this is what Swix do. He himself is also an AI ML engineer. So if I have to tell you about the rise of an AI engineer after all these uh, LLMs came, applied AI engineering got a very vast boom, and everything just started to get famous. Okay, like if you can use LLMs to make products, if you can make products in 10 days using LLMs, you can make them in hours. Now, he actually made this diagram. This diagram is very famous. You may have seen it on Twitter and a lot of other blogs. It is taken from this basic blog. You can go and read the whole blog. It is a very amazing blog. So this explains where the AI engineer sits in the whole spectrum of engineering of AI and ML. Now, it says that it is more product and user constraint. So an AI engineer focuses more on the user and more on the product side. Like, what do I have to achieve using the AI? It's not about that I have to use AI. It's about how to use AI to make the life of people easy and make a product that can make the life of people easy. So that is the work of an AI engineer in very abstract way. Now, going into the nuanced way, an ML researcher or a research scientist, what he does is he trains models, okay, and he does the evals. So it is like you are making the GPT model. If we take example of OpenAI, we are making the GPT model from scratch. That is what is the work of an ML researcher and an ML scientist. What the ML engineer does is it works mostly on the inference and the data. If you're cleaning the data sets, okay, if you are basically making the pipelines, if you are making pipelines on how to get inference from the base model that was developed by the ML researcher, you will be called an ML engineer. And if you go to a full stack engineer uses a product to build a platform that people can use. Now, it is the example is the front end and the back end of ChatGPT. Now, what the full stack engineer did was create a front end so that you can interact, and it created the back end so that you can call the actual model. So the model hosted by the ML engineer can be called using the backend, and the data can be shown to you. Now, where the AI engineer comes in this part, AI engineer uses chains and agents, and AI engineers uses the tooling and infra to automate the work of a full stack engineer using, let's say, cursor or something. And it also works a bit on the inference and the data side. Okay, it actually has the model. Let's say you have a model called llama. You will write the backend so you can make inference calls to the model, but using AI and things like cursor, that is built by AI using the tooling and infra built on AI, built I'm sorry, using the tooling and the infra built on AI, you can make a lot of apps that are very hard to make. For example, if you want to make an interface for Chat GPT, what you need is you need a front end, you need a back end, and then you need a model. You can basically send requests for inference. So what you'll do is first you'll take an open source model and you will install Olama in your laptop or PC. Olama is a library that can be used to run LLMs on your local machine so that nobody has access to your data. And it also provides you with an API that you can use on your network or local host to make interfaces. Now, what you'll do is you'll go to Cursor, you'll build an app, the front end, back end, and you'll use the inference API using the model you hosted, and you'll connect both, and then you'll make a full stack app. Let's say it's a chat with PDF app. We can say it's a chat with PDF app or more nuanced app than that. Now, what you used was you used AI to build that app and integrated AI in it, integrated the tooling in it, integrated chains in it using LangChain, we can say, or used agents in it. Now, if you're building for AI with AI, that's what the main work of an AI engineer is. If you want to read it more in a nuanced way, you can click on this link, and this is something called the Latent Space podcast, and it is explained in a very professional type of way on what an AI engineer does. So this is an image shared by Andrej Karpati. If you know Andrej Karpati, you'll know that he's a very famous scientist. So yeah, let's get back to it. What do AI engineers actually do? Now, coming to the part of what AI engineer actually does, I have explained to you in a way, like in a very vague way, what AI engineer does, but this is what is done by an AI engineer in detail. And I've explained a lot of it. So, first is the model evaluation and application. Now, working with models like GPT-4, Claude, and open source alternatives. Let's say you have an app, okay, and what you want to do is extract some, let's say, you want to do OCR. You have a receipts picture and you want to extract the total bill from that picture. Now, there are thousands of LLMs you can use. But what is the best LLM for your own use case? That's what you have to see and infer. Let's say I can use the Lava model, LLAVA, and host it on my local machine and run the entire workflow for almost free, because I know that for my use case this is the best method. I can get the best result divided by the cost ratio. So as an AI engineer, you also have to see that you have to keep the costs low of the client or the company or your app you are building, because we are depending on any third party API and the API is paid. So companies don't want to spend millions on these API calls, because it is a very big overhead for them, and also their data is going to some other server, so companies are not comfortable with that. So you have to see what type of model you have to use, and this comes using experience basically. So if you want to write content, I would say GPT-4 is the best model. And let's say your work is more about coding, you will know that as an AI engineer, if this company wants to make an agent that can code, Claude 3.5 Sonnet is the best model, because you know about the workings of that model. And if a company wants to keep their data private, this is some financial data, and they only want to do some little bit of analysis, you will know that okay, you can take a server from that company and host a very small open source kind of model, and then use inference from that. Now this is up to we can say your psyche and your experience on how you see other models, like how you differentiate each model from the second model. Let's say how I differentiate GPT-4 from Claude from Gemini. Gemini is very good at document reading. If you feed a very big document to Gemini, feed the same to Claude, feed the same to GPT-4, Gemini will parse the model in a very good way. So this is something that comes via experience, and this is what you have to do yourself, experiment a bit yourself and learn. So let's say a client comes to you and gives you a specific use case. If you are able to evaluate and tell them, okay, this is the best model that will give you the best result by cost ratio, you are on the right track basically. So coming to the second part, it's tool utilization. Now there are a lot of tools that you can use to build upon AI. Let's say there is LangChain. Okay, LangChain is kind of an orchestrator. You can make full agentic chains. For what is chain? Chain is kind of a sequence. So let's say first it is researching something, then it is verifying the facts, then it is writing a blog, then it is evaluating the quality of the blog, and then it is actually generating the final blog. Now that is a whole chain. If you were to um, make a chain of 5 API calls yourself, it would have been a tedious task, and you would have to integrate a lot of APIs, because while you're researching, you would use the Google API. While you're writing a blog, You may use some API that is used to search for some specific facts. Okay, an API that gives you something like tables, etc. So this is the basic thing. You would need to know how to use these tools like LangChain and Pinecone, the vector databases, all the things. And it is exploring autonomous agents like AutoGPT and Baby AGI. Now these have gotten a little bit of obsolete to make agents. Most people now use either AutoGen or they use Crew AI for making agents. Okay, so these are the some tools you need to know to be an AI engineer, because you need to complete the best amount of work in the least amount of time and the effort. And using AI, if you know LangChain, if you know Pinecone, you know all of these tools at your tips, you will be very good in making workflows. And the third thing is research integration. Now, as I mentioned in the first thing, you would have to know what model is the best for what type of use case. If you know the advancements in AI research, if you know the latest architectures that are coming, if you know daily innovations that have been happening, if you are on Twitter, you would know what is the best model for your own use case and how you can save companies a lot of money. Because a company will pay you and hire you as an AI engineer because they want to either improve their workflows, automate them, or they already have some workflows, they want to optimize them. Sometimes you are using GPT-4 or Claude model for your some specific use case, but that can be completed without even an LLM. Sometimes, like I have seen companies make these mistakes using AI where it is actually not needed, because some lazy person came, he couldn't write the logic, he just put an LLM in that, and that is not even reliable. So that is what you need to know. If you're good at research, if you know what is happening daily. Now, it's not like that you have to read every research paper. You have to follow the major parts. For example, Meta released something that can be used. Meta released a new model, let's say Llama Guard. So Llama Guard is basically a model that can be used to identify if the input coming is bad or not, if the input is useful for your own use case or not. If it is sexual, it can be blocked. So like these type of things, rather than building an own system from scratch, Meta has given you your own system. If you are on top of research, then only you know that there is a model, and you would not spend like 4 or 5 weeks fine tuning your own model. You can just take their model, use them. This will happen within 1 or 2 hours, only if you're at the top of your research. And the fourth thing is product focus. So the basic thing, the mistake that happens a lot of times is people want to make a product, but they force AI into it, even though there is not a lot of need of AI in that product. This is what you have to, like, as an AI engineer, know. Because if you use AI, you know that ChatGPT takes some time to process, and the output is not 100% reliable. But if you're writing code to do something, the output of that code is 100% deterministic. If you write a function to generate a random number, it will always generate a random number. If you write a function to clean some markdown files, it will clean those markdown files using the power of your system. And using LLMs, you can also clean using LLMs now. But if you write programmatic code to clean like your markdown files, it will run fast, it will be very reliable, you will exactly know where is the problem. But if you're using an LLM, you don't know when it will hallucinate. So these are some things you need to focus on your product and focus on what the people actually need, then only you can ship things. Got it? So that's the basic gist. uh just wait a minute, I'm having low battery, let me plug it into the charging. Just a minute. Hi guys, I'm back. Sorry for the interruption. And yes, we'll like take all of these questions later. Once everything is complete, we can take the questions. So yeah. So this is some things what actual AI engineers do. Basically, as an AI engineer, you need to know where to use, what LLM to use, and when to use an LLM. So that is the main thing if you would like me to summarize in one line. And you would also need to know when not to use LLMs. Like I explained in the last thing. If you want to clean some markdown files, go sit, chat with ChatGPT, give it some of your markdown files, say that this is the pattern I am having markdown files in, write me some code that can clean them. That will like boost up your pipeline by around 200 or 300 times, because if an LLM takes 5 seconds, it won't even take 5 seconds. The code will clean the whole, like the whole folder in 5 seconds. So the thing. Now, where do most people lack while building AI applications? It is the no understanding of business logic. Now let's be like honest with all of you guys. So when I was not in the business part of things, I was mostly like just a tech person who was trying to build things. I would build things for my own curiosity. But as seen that LLMs are mostly adopted by the enterprises. So enterprises have some business model, and they have some underlying business logic with them. We can just go and use an LLM with like any type of applications. Now, sometimes, I used to critique the government that why is the government not making chatbots? Okay, it is very easy to like host a local model and make a chatbot. Now, I talked with someone who works for the government. So using some of my connections I have with someone. So no, what they told me was we can use LLMs, but we need them to be 100% reliable. Why? Let's say we make a chatbot that tells people uh, about the results of their children. So I can go to the agent, I can give my roll number, it will give me my result. Okay, it will like call to some database and give me the results. Okay, just a second. Yeah, guys, sorry for the interruption. Yes. So, like I was talking about the business logic. Let's say the government introduces a chatbot that like gives you the result of your children. If you can input their roll number, they will get their answer. But LLMs are prone to hallucinations with numbers. LLMs are not very good with numbers, but like bigger models are, but still they don't know how to tokenize all of like the numbers and differentiate them from a single string. So LLMs are not very good with numbers. So let's say in the 1% use case where it doesn't get reliable, it gives a foul answer to something. Now the kid, now this is 1% case of that 1%. The kid can get sad, and he can also go towards like some people are very stress prone on studies. They can like they can do some things. I don't know if I should say the word or not. Harsh, can you cut it in like the post? So let's say a children, he took a very serious step. Let's say he went for suicide just because he got the result that was bad on his part. He didn't get the like correct result. The LLM hallucinated and declared that he is fail. So he can take a wrong step. So the governments have to worry about the 1% of that 1% part. Now this is business logic of the government or the business logic of any corporation who is dealing with a lot of people. Now most people who are not in corporations and are not working won't ever understand what is business logic. So it is very important for you to study how, when, and where are LLMs being used by companies. And if you guys want to see where real companies are using where real companies are using AI, I can like point you to a resource that is AI.engineer, the same Swix thing I told you about. This is the workshops. Now, if you go on their channel, they don't have a lot of views to be honest, but They have talks from the AI Engineer World Conference. Now, this is about MasterCard, how MasterCard uses LLMs. This is about NVIDIA, how NVIDIA uses LLMs. This is called about Prediction Guard. This is about how Twilio uses LLMs. You guys may have used Twilio a lot. This is about this is Jerry Liu. It is RAG for VPs of AI. He is the CEO of Llama Index. This is by Cohere, and this is by SourceGraph. This is by Mistral, and now this is by Tinder. How Tinder actually uses LLM to give matches. I'm sorry. This is how Tinder uses LLMs to give matches to you, and how they use trust and safety basic. This is how Discord uses all of the LLMs at scale. So if you want to see how LLMs are being used in organizations, they are not using LLMs for generation. They are using it for a very different use cases. I can send you the link in the chat if you guys want to see. So these are like some videos I also get my knowledge from. I wanted to point you to that resource. If you see these videos, you will understand what is business logic. And if you understand business logic, you can go and make it in any field. Because if you can save businesses money and make businesses money, they will give you a lot of money for that. So what 100 million is for a company, they'll give you 2 million for that, and you are just done with this. So this is the importance of knowing business logic. So this is a very like line I coined, and I like to use it, that the first rule of using LLMs is to know when not to use them. So if you are consulting a company who is using LLMs and saying that, oh yeah, we are cleaning some markdown files, or we are trying to augment our data. Augmenting is like, you have a data, you are trying to add a features column to that, let's say using LLMs, and I have 1 lakh columns. Okay, let's say I have a million columns. So the LLMs have a context window, right? Like 8,000 tokens, 20,000 tokens, 10,000 tokens. Now it can only process some chunk of that data. But if you need to augment the data, you can actually train a very small ML model and give it the data using NumPy and Pandas in batches. That will happen in like 10 or 15 seconds. But the LLM will take, I think, about an hour to process all of this recursively. And there is uh, no evaluation, plus there is a chance of hallucinations. So if you know where not to use LLMs, you can save your own costs, and you can basically increase your reliability, increase your trust, and yeah, not to be fooled by LLMs basically, because LLMs have gotten very good at fooling you. They will fool you in a way that you won't know. They are very good at persuading, and I'll discuss about this later. So the first rule of using LLMs is to know when not to use them. And I can bet that in 60% of the use cases we use LLMs, 60 or 65% type of thing, based on my experience, we don't need to use LLMs. We can eliminate the need completely. It's like, just don't use AI because it's hot, to be honest. Now, this was by me. So, yeah, got it. So, now I know this is getting a bit theoretical, but I'll get over it in like 15-20 minutes. But this theory is very important for you to know, because I've accumulated this theory like by watching a lot of videos, the videos I told you, by reading a lot of research papers, by reading a lot of blogs. Okay. So if you know this bit of theory, I'll give you the slides later. So like, just focus on understanding and listening. You'll get to know an idea about the only parts that you need to use from an LLM, and how to use an LLM, about what are your roles as an AI engineer. If you want to build like, not cool apps, I will not say cool, but you need to build production grade apps that companies can use in their business logic, and that's what you'll get paid for. Or if you do your own startup, or you want to build your own cool app, that's what you can follow loosely to get good outputs and reliable outputs. Basically, if 100 people are using your app, the 100 people should get a similar type of output. So now we'll understand some LLM metrics. So if you guys have ever like used the OpenAI's API or any API, this is like the three things that you use the most. So The first thing is temperature. Now, what is temperature? Temperature controls randomness in predictions. So now what an LLM does is basically, let's say you say, who is Napoleon Bonaparte? Okay. He will start by he is a French. And so first he writes the word he. Now how LLM knows that after he is will only come? LLM has a matrix. Okay. It will see, okay, the probability of is coming after he is the most high. So it will like use that word. Got it? So temperature basically has a value that ranges from 0 to 1, but but some companies have now scaled it from 0 to 2 basically. Got it? So I'm sorry, if the temperature is at 0, okay, the LLM will be very deterministic, like not deterministic in a way that it will always give you the same answer, but after like generating 10 or 15 outputs, you will see that it is only selecting some tokens and not very creative. It is not very creative at choosing other words. Okay, it will only use the words that are mostly used in the English language, because it won't be a lot creative, and it will be give you very focused type of outputs. But if you use a higher value of temperature, it will give you very diverse and creative outputs. Okay, so let's say you want to write a fictional story. You would want to set your temperature to very, very high languages. But if you're working with large scale data using LLMs, you would want the threshold to be around 0, because you don't want the LLM to go creative and make his own inference of your data. You just want that, okay, LLM, take some data, process it using just my data. Don't use any of your intelligence. I am giving you the data. But if you keep a higher value of temperature, it can actually infer its own creative thinking and make some imaginative data type of thing. So if you're working with some metrics, if you're working with some data, you can note it. If you're working with some metrics, if you're working with some data, if you want focused outputs and want the LLM to follow 100% of your instruction without deviating, set the temperature near to 0, like not completely 0, but zero point 0.1 type of thing. But if you are trying to like go full into creative mode and you want to write some things that have not been written before or try to experiment, always go to higher values. Okay, so now it is top k sampling. Now what is the top k value? The top k value, now as I told you that after he, how the LLM knows that after he is will only come. Okay, so we can say that he is a French mathematician. We can say this word. But after he is a, there are a lot of words that had come. French, we can say Indian, we can say South African, we can say Russian. Now there are a lot of words, but how does the LLM know what to choose? Now you now if you have a higher temperature, okay, if you have a higher temperature, the LLM will creatively choose, will also choose like the tokens of prediction that have very low probabilities to come actually. So let's say I say, what is Napoleon Bonaparte? He will say he is a like a French fighter or French person. But if I do higher values of temperature, let's say some companies give 0 to 1 and 1 to 2 also. If you make it 2, it will start outputting gibberish that won't even have like any type of meaning. Let's say I do it to 1.5, it will select Swedish also. Now that got wrong. And if you reduce the top k, it will have less options to choose from. And if you like increase the top k, let's say 50, it will have 50 tokens to choose from when it is choosing the next word. So that is what top k is. If you want to be very deterministic, okay, you need to keep your top k to around 2 or 3 very low and your temperature to very low. And if you want to be very creative, make the temperatures value very high and also top k's value very high. So it will also start considering tokens that have very low probabilities to come. And the top p is very similar to top k, but it is more flexible. So let's say you have a top p of zero point 0.9. Okay, it will only consider tokens whose probability exceeds your number. Okay, so probabilities are between 0 to 1. Let's say zero point 0.9, it will only like use the tokens that have probability of coming more than zero point 0.9. So but this is different. If you increase your top k, you get a lot of variation. But if you increase your top p, you are increasing the value of tokens that have the most probability of coming. So if you increase the top p, you are getting more consistent things. So if you want to be very less creative and very consistent, you need to use a very big value of top p, because that will only let's say it has a top p of 0.9, it will only consider the top 10% tokens. Zero point 0.9 is 90% of one, so it will only consider the top 10% tokens. Now you are getting the lower values of the temperature. Okay, you're getting the lower values of the spectrum that are most safe to play with. So this is some things you can take into account while generation. So in a just type of thing, in a summary type of thing, I can explain. If you want to be very focused on your data, if you want to do things that have logic in them, and you want your logic to always be bound, you need to use a lower value of temperature, you need to use a lower value of top k, you need to use a higher value of top p, because using a higher value of top p will make sure that you only get high probability tokens. Got it? If you want to be creative, use high value of temperature, high value of top k, but low values of top p. If you use top p is zero point 0.1, you can consider all tokens from that have probability ranging from 10% to ranging from 90%. So you guys have any questions related to that? What if the government makes their own LLMs from scratch, specific for each domain, not for numbers, but like general things like schema structure, there won't be any hallucination. It will work right. Look, Parampreet, the government can actually fine tune like their own things, like fine tune LLMs on their own data. They can use open source LLMs. But the thing is not about the training data, it is about hallucinations. LLMs are not 100% reliable. So let's say there is a chatbot, okay, that provides you discount if you are under some category. Let's say the discount is 5%. But if the LLM even hallucinated 1%, it will provide 18% discount. So the government is at loss at that point. And also people will start complaining on Twitter. People will start bashing them on newspapers or something. So the governments won't, to be honest, politicians like to be elected again. Okay. Politicians cannot risk all of this, to be honest, their reputation. So their reputation is more important, to be honest. Got it? It's not about the training. Uh, it's about hallucinations. If you can reduce hallucinations, and if you can convince the government that you have made something that is very reliable, okay, because if you are working with a company, your clients are in the well ranges of 1 to 2 million, let's say 10 to 20 lakhs people. But if a government will deploy something, it will be in the range of, like, let's say crores. Okay, so if there are a crore outputs, there is a very high chance, even if it is 1%, there is like 10 or 20 lakh type of requests that are malicious, and the government cannot deal with this, to be honest. They will be bashed in newspapers, and mostly, who knows, they lose the election. They cannot take this risk. How does the model chooses tokens out of the top k samples to autocomplete like thing? Look, when the model is trained, okay, I'm sorry, when the model is trained, it learns it learns the thing of which token comes after which thing. So let's say I'm saying he is a boy. Okay, is comes after he like 90% of the times. You know that after he is will come or 90% of the times. So when the model is trained in the pre-training part, it learns all of this vocabulary, and this is done using the attention mechanism. So I'm not going to explain attention in a lot of detail, but let's say it reads, if you read 1,000 books and you don't know nothing about English, you will start to see patterns that, okay, if there is a name, there is after that. If there is a he or she, there is after that. So that's how the model knows that, okay, 90% of the time is after that. So it will have a zero point 0.9 probability of coming after he, and R will have a probability of 0.003. So like that's how the model doesn't choose. The model has these probabilities logged in it. It chooses based on the temperature used. So if you use like a higher temperature, it will start going to the low probability tokens. If you have a very low temperature, it will only choose the high probability tokens. It won't take any risks, to be honest. Got it? Have I answered or anything follow up? Is cursor or superhuman use same method to generate code? So basically, the LLM is generating code. Okay. So yes, they use largely prompt templates, and we can say there is something called we can say bounded outputs, and there is a library called instructor. So yes, they mostly use the same method to generate code. but they have their own way of parsing the code that comes from the LLMs. So Cursor uses some of their own ways, Supermaven uses some of their own ways, but at the core, the architecture is very, very same. Bolt, Cursor, Supermaven, Lovable, every product. So it means if you have full stack engineer knowledge and well as some knowledge of ML and DL, this is called AI engineer. No, it's not AI engineer. Let's say if you have a full stack engineer, now you have the product knowledge, you can build a product that people want. Okay. But if you can use AI to like boost the development of the product, let's say I use Cursor to make something, that is one part of AI engineer. Second, when you want to integrate AI, like all these ML and DL models, okay, I don't have to like have any ML or DL knowledge. I just need to know how to use those models in the best way and in the most cost optimized and reliable way possible. That is what an AI engineer is. Got it? So like I personally also don't know classical ML and DL, but I know that this is a model. These are some creative use cases. For example, I showed you in this slide. This is what you have to do as an AI engineer. You don't have to learn maths for it. These are some workflows that you learn basically. So I'll share the slides. This is what an AI engineer does. Got it? So let's move to the next part then. The USP of my talk basically on how to architect production grade apps. Now, everything I'll tell you is basically my experience plus a very good blog post by a writer. She is called Chip Hewen. That is her name. Okay, you can also follow her on Twitter, and I have also share you the link in these slides. So she basically wrote this article on 25th July 2024. I've read this article too on how to build a generative AI platform, on how to build apps that are production grade. So what she does is she tells you the whole thing, and then she tells you the first part is to enhance the context, then is the guardrails, then is the modal router, then is the cache part, then is the actions part. So my now this part will be based on this blog. If you want to read, I can share it with you. And I have augmented all of her knowledge using my knowledge, what knowledge I had. Okay. So let's go. Now this is how to architect production grade apps. Got it? So let's go. So so the first thing we want to do while making a generative AI app, like based on this, is we hit the cache first. Okay. Now according to this diagram, I'm explaining like a very high level architecture of it. You get a query from the user, let's say uh, how to do matrix multiplication. You hit the cache. This is like a standard app where whenever a user is sending a request, you hit the cache and see if you have the result stored in the cache. If the result is stored in the cache or a similar thing is stored in the cache, you give the cached response to the user. If not, then you go into the whole pipeline. So what happens is सबसे पहले context construction is done. Now what is context construction? To answer your question, basically you need some context. Okay, the model may not always know the some shortcuts or tricks that your teacher has told you, but it is in a PDF and you have given the PDF, so it will make the context using the RAG type thing. RAG is retrieval augmented generation. Now it has some context. It will go to the input guardrails. So now what are guardrails? Guardrails is made to protect your LLM app, and also uh, companies use it to like be within compliances. Okay, so let's say I'm sharing some personal information with the LLM. Okay, the LLM always redacts the information. Redacts means removing and replacing it with some other placeholder, and then sends it to the model, because you don't want, if your user is, let's say, accidentally sends it bank number, I'm sorry, bank account number, you don't want it to be stored in some logs, because if your logs get leaked, the bank account will get leaked. So what will happen is it will go to the guardrail will see if there is any PII is personally identifiable information, and information that is unique to a specific user. Okay, It will redact it, remove it, and then it will send it to the model gateway. Now, what is the model gateway? So if you guys remember, the first thing I talked about is model evaluation and application. Now, let's say this app is having multiple type of things. Let's say it can also generate content, it can also write code, it can also read your PDF. Now, let's say the query is ki read this PDF. Okay. Now we know that for reading a PDF, the best model is Gemini. Now we will see the intent of the query and we will parse the query and pass the like our API request of the user using the model gateway to the Gemini, to the Gemini API. Okay, let's say the query is how to write content. Now we know that writing content, the best LLM is ChatGPT. We will send the request to the ChatGPT's API. Let's say the user is trying to debug some code. We will redact using input guardrails any personal information if there is, go to the gateway and send the information to Claude. Now, model gateway is like intelligent routing. You should know what query to send to what type of API. That is what you do as an AI engineer. Got it? If you see that there is a query that is related to some personal database, you will send it to some open source model that your company has kind of hosted somewhere. Got it? And after that it will come to the output guardrails. What is output guardrails? Let's say you gave something to the LLM, okay, and it generated something that had some racist tone. Now, if something like this happened with Google started generating some racist generations of people, okay, images of people, their first model, and Google faced a lot of backlash on Twitter. They have to take it back. Now this is what output guardrails are for. Before giving you the user the output, it checks if there is any like bad type of thing like racist, sexist, or if there is any not allowed word used here. So the output guardrails will remove that and then give it to the user the final response. Now, all of this seems very complex at first, but if you think it from a logical perspective, you will see that it is a very simple way to build an app. But what most people do is they get a query, they send it to the RAG database, and they get the thing back, they send it to the LLM, get the final response. Now, this is what most people do, but now you see that there is a lot of nuance in building these applications. Okay, now we'll go to the parts one by one. Now, what is context enhancement? So if you guys have any questions, have you dropped? Got it. So we'll complete this and then we'll go to the Q&A part. This is mostly the last part. So let's say the first part is context enhancement. Now what happens in context enhancement is you asked about a query, let's say how to do matrix multiplication, or you have a company database. You asked the company's database, what is the profit for this quarter? The query will go to the retriever and it will like retrieve your context basically and then give it to the model and you'll get a response. So this is called retrieval augmented generation, a very simple RAG pipeline. 99% of the people just finish their apps here. This is just a simple API and tool call and it ends for them. But there are additional 5 or 6 steps to making your app production ready. Now the next 20, this is basically 80% part of your system relies on this 80% part, but the next 20% is what makes your system reliable. Now this is what makes your system usable. The next 20% makes your system safe, trustworthy, and reliable. And that's what a business needs. The business cannot afford to lose customers. A business cannot afford to lose companies. This is what you do as a techie. And the next 20% is what you do as someone who understands some business logic. Got it? So there are some retrieval methods. Uh, First retrieval method is term based retrieval. So let's say you don't have a vector database, okay, but you have like 10 or 20 files. So for that, you can use term based retrieval. Let's say somebody is searching for how to do matrix multiplication. It will extract matrix multiplication and search for matrix multiplication, like the exact word in a lot of databases. Got it? And it will retrieve some things. Now, term based retrieval is used in sites like Google. If you search a term, a lot of things ranked things come up, okay. So this is used in Google. Then it's vector search. Let's say you searched for a query. This is the most used RAG method. It is like available on 99% of use cases. People use vector search. For vector searches, let's say I searched a query called what is matrix multiplication. It will be converted into vectors. The matrix, like the vector database I have, the query will be run against the vector database. I will get some context and then the LLM will answer using that context. So that is what vector search is. Okay. On a very high level, what vector search is. I'll discuss if people don't know what a vector database is later. Then there are hybrid approaches too. Let's say vector database don't work in some cases, term based retrieval don't work in some cases, but if you combine them they work very greatly. They cover about 90% of the use cases, and if you have a RAG pipeline having a 90% retrieval rate, like good retrieval rate, 90% is a very high term, to be honest. Got it? And one thing that people do in their, like when they even make this pipeline like a chat with PDF, we can say this is a very simple chat with PDF app. What they don't do is re-ranking. So what is re-ranking? Let's say you retrieve 4 or 5 documents after you run your query against the database. Okay, you will have 4 or 5 chunks. Now you cannot just give those 5 chunks to the LLM and take your answer. You can actually do this, but the answer won't be as good. Why? Because you don't know the 5 queries, the 5 documents that are returned, they have high quality data. So what you use is a new model in your pipeline that's called re-ranker. What the re-ranker will do is it will see that against the query you have, is there any relevant data, and rank those documents based on that. So if the number 4 document has the most relevant results based to your query, it will be placed on the first, and then second, then third, then fourth. So this is like how this happens. And sometimes people write pipelines that after re-ranking only the first document is sent to the model. So this improves your quality in the higher term. Like this improves reliability of the model. This improves your answering, your question answering systems. So this is something that is implemented. Then is tabular data handling and agentic RAG. Agentic RAG is when you don't give it a query, you give it a goal. That find me something, uh, like let's say you are saying, write me a blog about crypto. It will go to some blogs, scrape them, and then when the agent will have some questions, it will make those questions itself and ask the database and then give you a final blog. So in agentic RAG, RAG is happening. It's just you are not giving the questions. The agent is using your RAG tool. In tabular data handling, let's say you have a SQL database. You won't take the SQL database and vectorize it. Okay. Instead, what you will do is you will tell the LLM that this is my SQL database, and this is the schema of my SQL database, and you will give your schema of the SQL database to the LLM, that whenever you have to like answer me, give me a query back. Okay. Then you will run the query against your database, and the data you get, you will then send that data to the LLM, and then you'll answer accordingly. So this is the best method that even Swiggy uses. Basically, Swiggy uses this SQL to the SQL, the text to SQL thing. I can show you too. So like I'm showing you use cases of like companies that actually use LLMs in their pipeline. So let's see. Yes. So this is from Swiggy Bytes. This is a tech blog. They built something called Hermes, a text to SQL solution at Swiggy. If you read this, you will know how they went from a version one, like a very simple RAG system, to like this very big system. Like this is Swiggy's pipeline for just a text to SQL. Now there is no need to be like very overwhelmed by it or very intimidated by it. Okay, because Swiggy is a big company, they cannot take risks. That's why there is a lot of reliability in this. Okay, now if you want, I can share the link here. I'll put all of these links back in that too. So if you will like read a lot about how companies are using basically AI, you will get the best idea on how to use AI, because they are having a lot of data and they'll always go towards reliability and safety. But if you are building a small chat with PDF app, you don't know if there is a lot of reliability. That's how I learned that reliability is the most important for companies. That's how you can learn. And like this data is just available, uh, this data is available publicly, but it is not very publicized because people or tech influencers that you see, mostly people on Twitter, just like to make simple text to SQL apps that you can make in 5 lines, 6 lines. But if you see companies architectures, people are using, like the companies are using a lot of reliability rather than the generation part. They are focusing on the retrieval part more, that the data that is retrieved is actually relevant to our business logic. So this is a very very good blog. I read it like about 6 or 7 months ago, and this was also not 6 or 7 months ago. Yeah, almost 6 months ago I read it. So this is a very good blog that you can also read now. Yeah, like I'm giving you real life examples so that you know what I am speaking is actually being used. So like I'm not doing any fluff type of thing just to sound very knowledgeable. Got it? So got it. So this is guardrails. What I was talking about. I have also, like I'm in college and in the seventh semester, I researched on guardrails. So what are actually guardrails? First, the first part is input validation. So let's say I have this complete pipeline. Okay, this complete pipelines, the like every component of this pipeline is deployed on a different server, and whenever a request comes, this whole pipeline runs. And let's say running this pipeline costs me $0.3, and if there are million of things, so about $3 lakh are spent, $0.3 million are spent. Okay, if this whole pipeline runs on a million requests, but let's say out of those million requests, um, 90% requests are good, but 10% are malicious that are not related to. Let's say somebody is asking how to kiss something, some things like people ask these queries all the time. I don't know why, because I also have a real AI product and people ask very bullshit type of things. I don't know why. So that's why I know this is a very low level of whatever I told you. I have seen more weird queries than that, to be honest. So, but that are like not useful to our pipeline. But if our pipeline will run, it will cost us a lot of money. So what we do is we use input validation. When the input comes, we see that if the input is relevant to our pipeline, is the question the user asked, does the user has the intent to ask the question that we can answer. Let's say we are a finance company. Why will we answer who won? Let's say somebody is asking who won the cricket world cup in 1990 something type of thing. I know that my pipeline doesn't have answer to that question, to be honest. Why will I run my pipeline and then give the user no answer? I can reject it on the first place. Okay, so now what happened is you rejected it on the first place, it didn't go to the pipeline, and you saved the business a lot of money because there are multiple people like that in millions. You saved the business probably 300K type of some dollars. Okay, so this is what input validation is. And then it goes to output filtering. Let's say I give a query that is relevant, but the output that came was not relevant to the user. Like I cannot show it to the user because it is not compliant. Okay, let's say I have some documents which have some financial data. The user asked what is the, let's say we have a finance chatbot, what is the health of the Apple stock right now? It starts showing numbers, but those numbers are hallucinated. Now, as per your business or company policy, you cannot output numbers because numbers are always kind of subjective and they are changing every time, and your pipeline is not real time. So if the answer is wrong, the company can be put into legal trouble. So they always have safety and verification guardrails. So if there are any numbers, they will reject the output and run the pipeline again and say to the LLM in the second chain that please don't output any numbers. So this is how output guardrails are done. This is the part. And this is the model router and gateway part. This I have explained to you. So let's say there is a single unified API for all of these things. So you have an app that does customer support, that does review summarization, that does text to SQL things, and you have a model, and then there are many models behind the API. Now text to SQL is done best by Claude. The text to SQL query will come, the model will identify it and send it to the Claude model. If summarization is best done by ChatGPT, it will do it. The model gateway will send your request to the OpenAI's API. So you also save costs on this, because for coding, Claude is the best. And if ChatGPT is costly plus it is not as reliable, why will you send your thing or your user query to that API? Now, that is called caching strategies. Caching is very simple, to be honest. What I'll explain to you what happens. We don't even have to like see this. This is just a block that cache is always the first thing you hit when you make a request. So if you are engineers, you probably know this. We use Redis for caching. Okay. Whenever you are like doing a query on a database or something, you cache the answer. Cache is the first thing to be hit before anything goes into the pipeline. So let's say, as a company, some event happened. Let's say Zerodha's stock, we are a finance company, let's take example, and Zerodha's stock went up by, let's say, 50%. Okay, let something happen. So Nikhil Kamath is very happy, and you just want to see that, okay, what is the value of Zerodha stock now? You go, you search what is the value of Zerodha stock. It took us $0.3 to run the whole pipeline, but now I have a result to that answer. Let's say this is going in the news, and a lot of people are searching what is the value of Zerodha stock. I won't actually go into my pipeline again and answer the same question, because I will save the data that Zerodha's value is this. So whenever another user asks me, I have that answer in the cache, I will just give it back. So that probably saved me a lot of bucks. And as a company, I saved a lot of money. So money save is always money made. So if you have seen, like, in this session, I'm focusing a lot on saving money rather than making money, because businesses have a lot of backlogs, and whenever they are trying to use AI, they sometimes make like very, let's say, worst decisions, to be honest, very bad decisions about their architectures, because this is still a very new field, and there are not a lot of people that know how to build apps, and companies are hiring a lot, uh, we can say, noob engineers, to be honest, that don't know how to apply. But this is some strategies that I am telling you, you can apply to save costs for some company, and you will see that if you like make an app, okay, and like just make a sample chat with PDF app, but try to do all of these things in that app. If you present it as a project to some company, I don't know who will not hire you, to be honest. If you are like good 60-70% good at full stack, and you know all of these techniques, and you have actually applied it once, you can tell them, okay, if there is a simple chat with PDF app that another candidate, let's say there are thousands of candidates, if you have made this app, you can tell them that if a million requests came to their pipeline, um, you will be charged $300, but if you do it on my pipeline, just $70 are charged. Bro, I don't know, you will be instantly hired, to be honest. And that is a technique that I have used a lot, and good engineers used a lot, to be honest. The people use it. So this is something you can use in your resume and tech interviews too. But you have to actually build that, because if he answers your question and you don't know it, that is not a way to do things. So just go build 2 or 3 projects, or take existing projects and try to add all of this. So you have a better chance of getting hired, or a better chance of getting clients. Now this is mostly the last section about actions. So this is where you transition from a simple chatbot to an agent. Okay. What an agent is, it can take actions based on your behalf. Let's say you have a chatbot that whenever you ask about stocks value, it will send a message to your friend who also want to know about stock value. But you have just made a pipeline that whenever I ask for some stock value, send it to my friends group. Okay. So you can also write actions in your LLMs, and if you write actions, you have moved toward agents. This is now basically the AI agent part, because it can act on your behalf. So let's say you have a pipeline. Okay, it gave you that zero the stock value or something. Then the stock value will go to your tool. The tool will send an email to a lot of people that you may have already defined. Okay, so this is one thing you need to master. If you know how to write actions like update orders and send emails, you have made an AI agent basically. That is what an agent is. It takes action on your behalf. Agents are very like, today agents are said that there are autonomous agents, there are a lot of chains, there are a lot of pipelines, but these are like just fancy words to intimidate people, to be honest. An agent is something like you give it a query, it can take action on your behalf, even if it is one step. uh, it is just one step and it completes it in a reliable way. After all of this, it will be reliable, to be honest. If it is not a, let's say, a simple chat with PDF app, if you do all of this, the system will be so reliable that the last output that goes to your function or tool call, it will like 99% be reliable, and you'll complete your business logic, because writing actions is a part of business logic. Let's say a user signs up using your chatbot. Okay, now you want to send an email to that user. You won't write a different app just to do that and check your database. You will complete it using the own pipeline. So that helped your business logic, saved you costs again, and the user will be happy. So my only advice for building good apps is, like, whatever I have told you, all of this behind this is like technical information that can be grabbed. Okay, I will send you the slides, you can get this information, read these 1,000 times. But the main thing to use AI is to know when and where to use AI. So the thing is, first you have to, if you are building good apps, you have to understand your domain very well. So let's say, uh, I have a mentor who I am working with. Okay, he is into cybersecurity. Okay, so we were like building something for him, a chatbot or a RAG system or something. I was giving a prompt, but after seeing my prompt, he cut out a lot of things from my prompt and he inputted some information. Let's say I was um, I was writing something along the lines of, I forgot like the 100% thing, but I was writing something along the lines of testing LLMs. So he told me that it is called red teaming LLMs. So like what I was explaining in 4 lines, I explained using one word, red teaming, and now the LLM knows what red teaming is, because he was in his domain an expert. He knows that what words to write in your prompt and what words to give to give the LLMs to, and he also knows about the workflows of your domain. So if you understand your domain very well and you understand who is your user and what are their problems, you will always build a very good app. And this is not related to AI in any way. This is related to like business psychology type things. This is the basics of your business. Understand a domain very well, see what people are in that domain and what are their problems, and just solve them. AI is just a tool to solve their problems. So this is how you build good apps. An app is only good until it solves a problem. So let's say I have a very fancy UI but I don't do shit. So it doesn't make sense, the fancy UI won't make sense. But you may have seen a lot of business apps, like even if you go to banks, they have shitty UIs, to be honest. But the shitty UIs work. That's why they are still there. Okay, there is a reason of them being there. If you have seen some good open source projects, if you still see Oracle, if you go to Oracle's website, uh, so Oracle's website has, like, I don't like to say that, but they have a very pretty like old school type of interface. But that app is as reliable as it gets. Okay, if you post something, it is instantly posted. If you ask an answer, it is instantly given. That is reliable. That is the main thing. They have understood their domain and they know their user and their problems. So that's why it still works. So now, what are some common problems that happen while people are developing AI applications? So, like before this, if you guys have any questions, if you guys have any questions, you can like drop them, or I'll like move to the next, the last part. Got it. So not a lot of questions. So yeah, we'll move to the last part. And what are some common problems that happen while developing applications? Is the first thing is using AI just because you want to use it. There is not use of AI in building your application. Let's say you're cleaning down some files, you can clean them using your code. Okay, you don't need to use very like sophisticated LLMs to clean it. That is the first thing. You need to know where to use your LLMs, not to use your LLMs. Second is product research is not good. So people say that the model is shit. I know a lot of business owners that used like Chat GPT 1.5 years ago and they found it very shitty. But now after 1.5 years, they are saying that no, the model is very shitty. It was very shitty 1.5 years ago. But models have come along a very, very far way. Plus, one thing I've noticed is, let's say there is uh there is an app. So what that app does is it summarizes meeting transcripts. But you know what? The company that was building the meeting summarizer, it realized that people don't read summaries. You know what your user actually want. If you understand your domain, the user and their problems, the users only want action items from the meeting. They don't want to read the summary. Got it? So but they were saying that the model is very shitty, all of those things, just because their product research was not good. They don't know what their user wanted. If you know what your user will want, okay, you will always build good applications. Then they shifted and they got like a 20 or 30x boost in their revenue. The third part is, I won't call an API only. This would make me look less cracked. So this is a very hardcore Twitter quote, because if you are on Twitter, you will know that a lot of people say that they are cracked developers. Okay. But if your work is done using a simple API call, let's say you want to know weather, okay, you can go on Google and search the weather. Why are you making a full functional chatbot for it? Okay. And even if you want to make a custom app, you can just call an API, like do keyword search and get it. But people say that no, I will build a full AI agent for that, because if I don't build an AI agent, I won't look cracked. To be honest, cracked means like very technically sophisticated, very technically knowledgeable. But that is not the case. If your app use case is very simple, just keep it simple. Got it? So as I explained earlier also, 80/20 rule also works in AI. When you are making a chat with PDF app, or you're chatting with some document database, setting up the RAG pipeline is 80% of the work. But uh, the next 20% of the work you do is what in separates you from all those people. Okay, if your app is reliable and is saving costs for the money, is saving cost for the company, so that is the only metric that will make you successful. If you are an AI engineer, why? If you are an employee, that the metric is same. If you are consulting, the metric is same. If you are a startup, the metric is same. So if you want to like get a real world gist of what I'm speaking, the 80/20 rule, go and see the AI engineer videos I have shared. So the fifth thing is, fuck humans, it's AI all the way. Forge human evaluations. So whenever you are building an app now, let's say I'm building something for cybersecurity and I am not from cybersecurity, what I will do is, what people do is they set up evaluations. Got it? So they will use another LLM to evaluate the LLM outputs. But the LLM outputs, like the way they judge LLM judges LLM outputs. Okay, these are called LLMs as a judge. When an LLM judges other models' output, it is reliable, but it is not 100% reliable. So it is like considered a best practice to have a domain expert in your team if you're specifically building for a domain. And coming back to my same thing, all of these 5 points follow this thing, that understand your domain, the user and the problems. If you have a domain expert, as I shared like example of um, my mentor telling me what red teaming is, because if he wouldn't have told me that day, maybe I would be still tweaking my prompt and still not knowing what he wanted to do. So yeah, if you're having a domain expert in the team, and if you are building AI, if you are not expert in that team, at least have a domain expert of that domain who doesn't know about tech, but he can actually judge if the outputs from your app are good or not. Let's say you're building a research paper generator, okay, that you can give your raw data and get a research paper written. If there is someone who has written 20 research papers himself, he can evaluate your app and give you like very good feedback on if your app is good or not. So yeah, this is the Q&A section. I've like completed all of my formal presentation. So if you guys have any questions, anything related to anything, you can like drop them. Uh, any good complete AI engineer course? Yeah. So like sort of AI in the courses and things about AI engineering is you can learn the basics. Okay, you can learn RAG, you can learn AI agents, you can learn guardrails, but like there are a lot of resources for that. When you lock in the basics, okay, uh, you have to experiment on your own. You have to like make a basic understanding of what types of apps you want to build, make a basic understanding of models, what model is good at. Okay, you have to experiment, then only you know how to build good apps. Okay, there is not a complete AI engineer course, to be honest. You won't find, because you won't even find a book, because writing a book takes 3 months, and in 3 months like the world in AI shifts. It shifts in one day too, you know it. So not a complete course, but if you want to follow something, you can follow short courses from deeplearning.ai. Like that is something I would recommend. I am a full stack web dev and I badly want to go into agent development. What would be my first step? Okay, so like if you're a full stack dev, you have like the basics logged in. You know about systems, you know about cache, you know about like how to build good apps. So that is a good thing. Then you want to go into agent development. So before going into agents, you should know how to build simple chatbots or LLM apps. Okay, first lock in that basics of how LLMs work, then go into first principles of what an agent is. Okay, an agent is like something that can logic reason on itself, and then use some things like actions to fulfill your purpose. So if you want to go into agent development, learn about LLMs, integrate LLMs into your apps. Okay, make 2 3 apps, then you will know about what LLMs are in and out. Then you need to go into agent development. And if you want to develop agents, there are 3 libraries that I recommend. First is PhiData. PhiData is a library. I can show you guys PhiData. This is like a very good library. And there is a library called Crew AI. Crew AI is used to build agents. You can go and build agents using Crew AI. Then there is Autogen. Like Autogen is by Microsoft. It is very code based, to be honest. But PhiData, I find PhiData is a good intersection between Crew AI and Autogen. So you can use PhiData. Is 3 4 months good enough to learn and become good at it? Should, no, you don't need to have math knowledge. Look, that's what I explained now in what an AI engineer is. You don't need to learn math. You need to be good at applying LLMs into business logic. You need to take some logic. You need to know how to automate it using LLMs. If you can do that, you're good enough. Yagiraj, how to cache system prompts. So it is a basic. If you know about Redis, okay, you can set up a model. Let's say somebody asked about what is price of Zerodha stock, and now you can ask the same question in 10 type of ways. So what you will do is let me explain to you in this, like how to like okay, so like caching prompts is, it is just a key value store that you know is in most caches. So like you will have a database like this. Okay, what will happen is, first you will have a user query. Okay, the user query will go into the cache, and if there is nothing on your cache, it will go and then generate a response. Then give it back. Now this is without caching. Okay, without you. Now what you will do is, whenever you get a user query na, and you send it to a cache, but when you have a user query, you send it to like a model uh, that can ex- extracts intent. Okay, let's say the user query is about what is the price of Zerodha stock. Okay, so the user will it will extract the intent of your query, that is Zerodha stock price. Okay, and it will save the Zerodha stock price. Let's say it's some XYZ value. Okay, in the database, it is stored here. So then whenever a second user comes, and it will ask for the question. Okay, let's say he asked in a different way कि Zerodha के stock का price क्या है. It is in Hindi. Okay, it will convert and go to cache, and it will see, okay, there is something related to Zerodha stock price here. Then it will say, okay, I have the exact value, and it will give it back to the user. The like whole pipeline didn't run, it gives it back to the user that way. So for extracting the intent, you have like a different NLP type of model that you can train. Okay, you can train a model that extracts entity and intent. Got it? Anurag, should I master LangChain also to build agents, and also where can I learn about these agent development libraries? Bro, like if you want to learn about Phi data, just search Phi data, go there. There is the docs. Just read them. Beautiful docs. You will know about any library. Almost every library has docs. You can learn them. Should I master LangChain also to build agents? LangChain is used a lot. But if you are like using it more for development purposes, yes, you can use LangChain. If you are using it for production purposes, I prefer either PyData or like, you can learn LangChain. But I find it uh, लाइक मतलब बिना किसी बात के कॉम्प्लेक्स है वो काफी फालतू तरीके में टू बी ऑनेस्ट इट इज कॉम्प्लेक्स उतनी जरूरत नहीं थी कॉम्प्लेक्स होने की इट इज वेरी कॉम्प्लेक्स unnecessarily so yeah you can use phi data is good why perplexity AI is a big thing like it is still using the LLM no perplexity is not only using LLMs when you like go to perplexity let's say and I ask is who is it Bandhu like I ask about myself. Okay, it knows about me that I am an AI engineer and entrepreneur. It is actually pulling all of these websites in real time. Google is not even faster than that. If I search Hitesh Bandhu, it will take some time, but it pulled out all of these sources. It extracts all of that data. Then it gives all of that data to an LLM. Then you get an answer. Now, this just happened within a blink of an eye. So they are having something. So this has to be a big thing to be honest. It is using existing LLMs, but it is giving you the power to search the whole internet. So yeah, they have some pipeline. I don't know because they are closed source most probably. But like Perplexity is so fast at searching, so fast. Yeah, literally it's so fast. So yeah, that's their USP to be honest. And they also have multiple models. You can use Llama. You can use. I don't have. I used to have Perplexity Pro subscription. I don't have now. But you can like go here and select what type of models you know. Uh, if you want Claude, if you want Sonar, if you want Diego. Yeah, this is like their USP. Hmm. So, any other questions, guys? Let's say you want to build a agent that can book a hotel for Thailand, etc. How to design it roughly. So look, how an agent works is first you give it a goal, okay? Now then you give it a query. I want to book this hotel in Thailand, let's say for example. Now what a human will do, okay? You go, you search on Google, you will get a hotel, okay? Then you will go Harsh is laughing. So you'll go there and then you'll search for the hotel, then you book it. Now if agent wants to do that, first it should be able to search, so you need to have a tool that can search, okay, like a search tool on Google. Second, you need to have a tool that you can use to interact with the website. That's how it can click on things on the website. So you need to have two tools. First is the interaction tool, second is the search tool. If you give these tools to your agent and say that you want to book a hotel, it will book it for you. So you need to like think about think like a human. How a human will do the same thing. The human will do the same thing like this. Okay, how I can provide these capabilities to the agent. You can use tools. You can make two or three functions. Then you can use it. Getting results from multiple sources like super fast with images. Like yeah, if we're talking about perplexity, they are very fast to be honest. But I have no idea why are they very fast. I don't know to be honest. It's because they are closed source. Uh, and they have like crawlers going on 24/7 on websites. What will the cost of running an AI product with 1,000 to 10,000 users? It depends what type of the product is. Let's say it is a chatbot. Now there is a lot of requests in a chatbot. So it depends on how many queries you have. Let's say 10,000 users and every user has 100 queries. So it will be like about a million requests. So for a million request, if one of your request is about 300 tokens, you will have 300 million tokens. So 300 million tokens into the price of a million tokens, you can see what is price of GPT. Let's say you are using GPT-4. So these are like input tokens. The price of output token is $10. So 10 into 300, it will be around $3,000, roughly speaking, for 10,000 users if they're making 100 requests per day. How can we deploy a AI agent? Let's say and deploy a project in Vercel for live. To deploy that agent, you need to have a backend. Basically, the agentic work is happening on the backend. So you just need the user to see the answer. If the user needs to see any processing, you can send the logs from backend to the front end and stream them real time. That's how the user can see what the agent is doing. So yeah, it is pretty easy. If you want to develop AI agent things, there is a library called Chainlit. If you have heard about Streamlit, this is like yes, this is very easy. Like you can build AI agents with it. Like if you want things like this, you can see the video. It will show you it is using RAG agent, and this will happen in like under 10 minutes. You can configure it under 10 minutes. You can use Chainlit. Why an agent for booking? भाई वही जानता है ये तो मैं नहीं जानता भाई. This might cost more than traditional booking. नहीं ऐसा नहीं है like how many websites will you go to yourself, but an agent with a tool it can go to 100 websites at one time. Maybe you get some better deal somewhere, like you don't know. Most of all the libraries are Python, so one should understand Python well to build, or I can do it TypeScript. No, most of the libraries are in JavaScript too. As far as I know, most libraries are in JavaScript, but if even if they are in Python, if you know JavaScript well, I don't think it will be a problem for you to learn Python, because learning Python is a very good like opportunity, to be honest, this time. Because if most of the new things that get released, first they are released for Python, then they are released for TypeScript. They are released for TypeScript eventually. So yes, I will say learn Python. It won't take like more than 15 days to learn Python. Yes, so it is beneficial to learn Python, but mostly like if you're using LangGraph or LangChain, they are available in TypeScript. Don't ever to learn engineer. Uh, Good YouTube channel. Like it's not. Like, to be honest, like, let me give everyone an example, to be honest. Have you heard about SQL? Everybody has heard about SQL, okay? SQL was probably developed 30, 40 years ago. Now it has matured enough after 40 years. Like, 40 years is the age of SQL, to be honest. I don't know about the real value. We are just approximating it is 30, 40 years. At least 30, 40 to hai. That thing is so matured and used by so many companies that they are now, it is very reliable and there are best practices for it. If you run a query on a like database with the same schema in any part of the world, you will get the same answer. But in AI engineering, everything is so new and so experimental that there is not a good YouTube channel or even a book to learn AI engineering. Mostly what I have learned via research and I have learned via experience of other people. That is the best thing you can do. I shared you about AI.engineer. Okay. You can go there, see how companies are implementing, try to implement the things yourself. Got it? So, like, I don't know about a good YouTube channel. I told you about like a good thing to know how companies are implementing. You just need to know the basics. Okay. If you know the basics, you can chain things together and experiment. The basic thing is experimenting. If you experiment, you are at top of everything. If you can research and experiment, you are at the top. Thanks for the session. Thanks, bro. Thanks to you too. So, any other questions? Yes, thanks a lot, bro. How much I can make as AI engineer? You know what? Be an AI engineer, make 10 agents. Then those 10 agents can make 10 more agents. Then those can do the work and you can make infinite money. Infinite money glitch. Like, it's upon you, bro. If if you can work for 24 hours a day, you'll make more money, to be honest. But there is a lot of scope for AI engineering, like getting out of मजाक से हटके. ऐसे मैं वैल्यू तो नहीं बता सकता भाई. आई नो पीपल जो 25,000 भी कमा रहे हैं. आई नो पीपल जो 25 करोड़ भी कमा रहे हैं एजेंट से. तो डिपेंड्स ऑन यू. हर्ष सेड 7 करोड़. सीरियसली हाउ? ब्रो, देयर सेविंग बिजनेस इज मनी. मैंने जैसे बताया, मतलब 25 करोड़ अभी भी लो लो वैल्यू में है भाई. It is in the lower ball type of thing. People are making a lot of money, bro. Like, I'm telling you, people are making a lot of money. Saving business is money. They are making a lot of money. It's not freelancing. It's mostly they have good distribution. Okay. दूसरा कि they know how to sell themselves. SaaS भी करते हैं. It's like you build a company that gives services in AI. Okay. And then you approach a company, you tell them, okay, this is a pipeline, this is so fucked up, I can save you like 100 crores or something. Like, ऐसा कुछ बड़ी कंपनी में जाओ. But ये है कि बड़ी companies don't trust you very easily. So even I have not worked with a very big company अभी तक. So yeah. But मतलब 25 करोड़ इज इन रुपीज, तो डॉलर्स में कन्वर्ट कर लो, थोड़ा कम हो जाता है. तो कितना ही होगा? 25, 1 2 3 4 5 6 7 डिवाइड बाई 85. इट्स लाइक 2.9 मिलियन. अब थोड़ा कम लग रहा होगा. 2.9 मिलियन तो बना लेते हैं बंदे. नो इश्यूज.
I think chat message you're not getting, so let me just check the Luma registrations if we have questions from there.
या.
Let me pick a fun one. How do you manage stress? Oh, you wrote this for yourself. Oh, oh,
ये
scam.
ये मैं- ये मैंने
Scam.
खुद के लिए लिख दिया.
So tell us, how do you manage stress?
बेसिकली द बेस्ट वे टू मैनेज स्ट्रेस इज डोंट गेट स्ट्रेस्ड. और तो कुछ नहीं है. जस्ट
Well,
एंजॉय लाइफ.
this is like how to make money.
या.
There's you see the book How to Make Money, work hard. Like, like that, doing the same thing.
Oh,
Okay.
वो book ने how to understand women and the book is empty.
Oh my god. Okay. How to begin? Actually, we have covered this. Are we going to learn about how to fetch APIs? This is also. Hmm, I think we mostly have covered
Hmm.
the questions through the chat only. How AI production lands are for privacy and security sector. I think guardrails kind of covered
Yeah,
that. So
Adril's covered that. How to scam people online.
that is probably you should watch Jantara.
No, first don't tell people that you are going to scam them. Now they know that you are going to scam them.
Yeah, be smart.
Please. You failed on the first step.
What are you personally excited about in AI? Like which particular domain? Like AI generate video generation, image generation, agents.
Like I'm not very excited about some specific part, but I'm more excited in how AI can like take decisions on my basis. To be honest, okay, like I don't need to be available for it. I can just be like कि हाँ भाई मेरा काम तो हो रहा है और जिस दिन मैं इतना श्योर हो जाऊं that will be the day I'm more excited in AI.
Got it. Got it. Got it. Got it.
Because it is not a lot of reliability right now.
Right.
And अभी क्या हुआ कि most of the models have hit a training wall क्योंकि अब और डेटा तो है नहीं.
There is a new Titan wala paper from Google that I also want to read.
Mm-hmm.
It might be
Yeah.
the successor to the attention wala paper. I think we should do a session where somebody explains the whole attention wala paper because I have never still I haven't gone through it.
There is a video by Andrej Karpati. He explains what is attention. I don't think that there is a good way above that. Like उससे अच्छा कोई resource नहीं है.
Bro, you just said Andre's car party. That is like I got the feeling Pankaj Tripathi. Like what are you doing here? I people pronounce it like
He
Andre
he
Karpati.
he is Andre Karp. He is Pankaj Tripathi of LLMs.
वो ये इंडियनाइजेशन हो गया ना नेम का. I get it. I get it. But yeah, I think this has been for like 2 hours. People and ten plus people have sticked like almost for
Mhm.
double of the time. Thank you so much, guys. Um, Obviously, you stayed around probably because you loved the content. So thank you so much. Still, if you have any questions, we have the WhatsApp group. You can tag Hitesh. You can ask there whenever he gets free time. He will respond. And thank
Thank
you.
you, bro.
So the recording for this usually gets uploaded in 1 2 weeks on the YouTube channel. So if you want to share the recording with a friend or if you want to review it, just thank you, Vardhan, and just stay subscribed on the channel and you'll get notified when the video comes up. We'll also probably do a blog post and a video because so that text is easier to go through and video
Yeah.
when to actually want to see the whole thing.
Yeah,
So
Harsh, when you like are done recording, if you get it, can you send me the audio? I can make notes from it. Like I have a content pipeline type of thing.
okay, okay, nice, nice. Yeah, sure, sure. Like some notebook LM style.
Yeah.
Cool. Yeah, yeah, sure. I think recordings, the raw recordings, you can get just within an hour of the session ending. I'll send it across, and the edited version we send out on YouTube. Editing takes a little bit of time. That's why. But yeah, the raw probably can share with by the end of the day. So I think we don't have any more questions. So
Yeah.
yeah, thank you so much for everyone joining. Thank you so much, Hitesh, for taking a
Thanks
lot
a
of.
lot, Harsh, bro. Thanks a lot.
And yeah, if we have a session tomorrow also, guys, from Tushar. If you're interested in building your own SaaS, you can join us tomorrow. And as always, we have something or the other coming up on each Friday. So just say subscribe on the Luma calendar, and hopefully see you all of again very soon.
So if you want to like see the practical of what I told you tomorrow, You can see it. One part of building.
Yeah, beautiful way to describe it.
Yeah.
Cool. See you everyone. Have a
Okay.
good night. Have a
Thanks a
good
lot, Harsh. Bye bye. Bye everyone.
thank you. Bye bye.